Okay, in this video we're going to look at doing long division on a polynomial. We can also do something called synthetic division, but I find that this is a bit more of an intuitive method and easier to remember. So we'll start with this blue polynomial, x cubed and so on, and we'll divide it by x plus 2. All we have to do is compare the leading terms. We have to compare x to x cubed. How many times do we have to multiply x by to get x to the power of 3? Well, the answer is going to have to be x squared, and the next step we have to find out is what happens when we divide by x squared. So we're going to multiply x squared by this red term that we're dividing by, and it's going to give us x to the power of 3 plus 2x squared. So that's the first part of our division done. We're just going to remove this to find out what's the remainder when we do this division, when we divide by x squared. What's going to give us this green term taken away from the blue term to find the remainder. X cubed minus x cubed gets rid of the x cubed terms and leaves us with plus 5x squared. We'll bring down the x and the negative 18 because they weren't part of our division so far. We're just going to repeat the process and say how many times do I have to multiply x to get 5x squared? Well, the answer is simply going to be 5x, which will then multiply by the red term again, 5x times x plus 2. And that's what happens when we divide by 5x. We'll get 5x squared plus 10x. And once again, we'll remove this from the blue polynomial to find our new remainder. And we'll keep repeating this process until we get to the end. So I'll subtract all of this green part. The leading term will disappear, which is the point of long division. We're just working one term at a time. Negative 9x minus 18. And we have to do this one more time. How many times do I have to multiply x to get negative 9x? Well, it's going to be x times negative 9. We'll show this on the side here in our working. You don't have to do this part, but just for the first instance I will. That's going to give us negative 9x. Negative 9 times 2 is plus minus 18. And we'll subtract this whole term, this whole green part from the blue part to find our remainder. We'll subtract all of this, and the negative 9x's will cancel out. Give us a 0. The negative 18's will cancel out, and we're left with just 0. So this is our remainder. In fact, we have no remainder, and that's because the x plus 2 term in this case was designed to be a factor, and you could have checked it using factor theorem at the beginning. X plus 2 is a factor of our blue polynomial, hence no remainder. So x cubed plus 7x squared plus x minus 18 divide by our polynomial term x plus 2 gives us the answer x squared plus 5x minus 9. Now you could have done this using comparing coefficients, like in the previous video, which works nicely when you've got no remainder, but not so nicely when the number we're dividing by, this red polynomial, isn't a factor, like in this next example. So I'm going to choose, not particularly chosen, 2x minus 2. It is very likely that this is not a factor of the blue polynomial. We'll check it. So 2x times what gives you 6x to the power of 4? Well, it's 3x to the power of 3. I'll multiply that by this red term to see what we have divided out. 3x squared times negative 2 is negative 6x cubed. I'll subtract this from our blue polynomial, and the remainder so far will be negative 3 minus negative 6 is positive. Positive 3x cubed. Bring down the x squared term, bring down the linear term, and bring down the constant negative 4. And repeat. How many times do I have to multiply 2x to get 3x cubed? Well, it's going to be 1.5x squared. Multiply that by the red term. 1.5x squared times 2x is 3x cubed. 1.5x times negative 2 will give us negative 3x squared we'll subtract that term again. Once again, we'll eliminate the leading term. 2 minus negative 3, that's 5x squared, bring down the terms we haven't used yet. Okay, and you can see we're going to have to repeat this at least once more. 2 times what equals 5? Well, it's going to be 2x times 2.5x to give us our blue 5x squared term. And negative 2 times 2.5x is negative 5x. We'll remove this, bring down our remainder. We're going to subtract that whole term. We're subtracting the whole term every single time, the whole line, not just the first term. I should have put it in brackets. 10 minus negative 5 is positive 15x minus 4. Right, once again, 2x times what equals 15x? Well, it's going to be times 7.5. 7.5 times 2x equals 15x. 7.5 times negative 2 gives us negative 15. Right, we'll subtract those. The leading term will again disappear. So that's good. But negative 4 minus negative 15 gives us positive 11. And last time we had a remainder of 0. This time our remainder is 11. It's not equal to 0. And that whole thing is just because this term that I chose at the start was not a factor of our blue polynomial. So that factor theorem says that is not a factor since the remainder is not 0. We could just write this as R11 at the end, but don't forget we were dividing every term as we went by this red polynomial 2x minus 2. So I could just write that as a plus 11 over dividing polynomial 2x minus 2, and that there is the resulting polynomial when you divide through. So that's our answer there. Let's have a quick zoom in. Oops, this x squared term, this x term shouldn't have been there. That's a mistake. And just to note, you could do this if the term that we're dividing by was an x squared term, for instance. It just means that you need to adjust the answer. That would have been x squared as well, but everything would just follow the same procedure.